Hello, a very warm welcome into Raising the Dots, connecting you with the people, ideas and technology reshaping the world of Braille and Tactile literacy. I'm your host, Dave Williams. Coming up this time on Raising the Dots, we'll be meeting the Portuguese man who is hoping to make technical drawings more accessible for those of us who are blind or low vision. Before we get into this month's episode, a couple of notes to share with you. Dot, of course, will be at the summer conventions at the National Federation of the Blind and the American Council of the Blind in July. We do hope that you will come along to one of those events if you're in North America. And at NFB, we will be hosting a face-to-face session, how DotPad fits into your active life, and that's on Monday, July 6th between 12 and 2 p.m. in room 205. All the details you can find in the National Federation of the Blind convention program. And just before then, actually, on June 22nd, we'll be hosting a webinar concerned with developing for DotPad. That's at 5 p.m. UK on June the 22nd, and you can find out more details about that and all the goings on, latest news and events where Dot will be on our blog. You can go to blog.dotincorp.com. That's blog.dotincorp.com. Vítor is a Portuguese researcher developing a solution to enable people who are blind or low vision to access technical drawings such as circuit boards, flowcharts, and much more. And Vítor joins us now to tell us more. Welcome in, Vítor. You said just before we started recording that I could also call you Victor. Welcome. Good to have you with us.
Thank you, Dave.
Tell me a bit about your work, because you are interested in this area of tactile experiences. Tell us, give us the kind of the short version. What is it in a nutshell you are doing?
I have lots of things doing in my life. So professionally, now I'm an accessibility expert, and I work in a company that does websites for the government, and we must comply with certain laws, of course, and I'm there to help them comply with those laws of accessibility, online accessibility. But my academic career, I'm doing my PhD in the doctoral program of digital media, and for my master thesis, I've explored the way blind people could perceive visual images by sound. In my PhD thesis, I'm stepping a little bit forward, and I'm trying them to build drawings. And I'm using the DotPad for that. So in a nutshell, that's what I'm trying to do for my PhD thesis.
And this work is informed by your accessibility work on websites, is it?
Yes and no. This experience is a little bit further in a way, I believe, because the experience of someone navigating the internet is a deal, and in the field of technical drawings, because that's what I'm thinking about while developing my app, is another different field, another different approach. So, but that maybe the internet accessibility gave me some sense of what is to have an impairment, a visual impairment, for example. And I'm trying to cope with those demands for persons with visual disabilities and trying to transmit them the correct information of an image.
Right. And so the problem you're hoping to solve is to make technical material more accessible. Yeah. Okay. And what brought you to this field? Why you?
Well, the field of accessibility was introduced to me by a colleague, a former colleague at the University of Porto, that just explained me stuff that I really haven't thought out about that matter, how people with disabilities were looking at web pages, was their experience using the web pages. It was almost like a gut feeling. I enjoyed that information. I liked the field, and I started to move things forward inside the University of Porto, because back then I was developing the information system of the University of Porto with a big team, of course, and I was responsible for the web design. But that accessibility field brought me some problems that I haven't thought before, and so I started exploring them. And when I entered my master thesis, and I was able to choose a subject, I decided to go for accessibility. And why technical drawings? Because I have another PhD in mechanical engineering, and I thought that if a person loses the sight during the cycle of the life for some unfortunate accident or something like that, if that person is a mechanical engineer, for example, does it mean that the person should stop what the work that that person is doing and consider other jobs? Why not developing the skills already learned and try to continue with the profession that that person has? So there's a gap there. So my main focus here is to provide persons ability of comprehend and interpret technical drawings using, in this case, the dot pad.
Can you describe some of the characteristics of technical drawings that make that material especially problematic?
On one side, technical drawings are simpler when compared, for example, with art, okay? Because technical drawings, we are talking about geometric shapes. So in a way, they are simpler, but in other way, they can have levels of complications. They can be very difficult to comprehend for a person, for example, who doesn't have vision, because we will get to the point where the user cognitive load will blow up. So we must transmit all the information in the drawing and respect that kind of cognitive load, because we have to transmit the information first through various channels. So we are talking about hearing, we are talking about tactile feedback, okay? So that's where DotPad enters.
And when you talk about technical drawings, let's just be really specific about what you mean. Are we talking about schematics or flowcharts or all of the above?
You can interpret as all of the above, okay? For me, as a former mechanical engineer, I mainly think about schematics. For example, a camera, a filming camera. You must have the plans to build the filming camera. And those are technical drawings. Or a car, or a motor, something that any object has or can have a technical drawing associated with that.
Right. So all the components would be, or some of the components would be represented in the technical drawing.
Ideally, all the components, yes.
Yeah. And those components obviously need labels, and they have a spatial...
certain dimensions, yes, spatial
relationship,
spatial coordinates and relationships with each other, all of that.
Okay. And so you started thinking about this as audio information through sound originally? Is that,
in my PhD, in my master thesis, it was only conveyed by sound. And person would listen to the description of the drawing. And I have what I call a gestaltic approach. So the theory of Gestalt, of looking at things and the way the brain interprets things. So I built a navigation system that obeys some of those Gestalt laws. So I begin by explaining the full picture, and then the person can explore the drawing through multiple levels or increasing levels of detail. And then I establish simple relationships of the objects in the space and between them. And then if the person wants, they can go further and investigate a part of that drawing or a particular shape and know all the details about that. Because we mustn't forget that when a person is working on something, on a mechanical object, for example, maybe that person is integrated in a team and must speak with other persons, some with disabilities, some that don't have disabilities. And they must understand the dimensions, the form of the object, what the object is doing, where it belongs, and so forth.
In this field, what are some of the advantages and disadvantages of an audio-only approach?
I know that a person with visual disability, when that person gets the information through various channels, for example, the tactile and the audio, that person will perceive the information better than if you just convey the information through only one channel. So that's why I try to explore that tactile approach to enrich the experience of the user and to convey them the information they need.
Right. So it sounds like what I'm hearing is there is research that absolutely supports the idea that multimodal learning is much more powerful, will lead to deeper insights.
Yeah.
Because we often say this, right, when we're talking about tactile technology and demonstrating tactile technology, that multimodal learning is more powerful and more impactful. Can you just speak briefly about that? Like, what are those findings? Why is that the case?
Well, we know, for example, that when a person loses sight, for example, the other senses they develop more than persons who don't have that disability. For example, we know that the visual cortex is invaded by, for example, the hearing cortex or other senses. Okay, the brain adjusts its behavior to the new condition or to the condition that the person was born with. And so, for example, a blind person can have better tactile sense than a person who has vision. And maybe that person with a visual impairment has a better memory for things or sees the world in a different way. But on the other hand, there are some things that connect persons with visual disabilities and persons who don't have visual disabilities. For example, one thing that I learned is that persons with a visual disability can construct an image in their brain. Of course, that is more easy to do for persons who lose their sight during their life. But for persons who were born blind, they have some kind of mental image of things that surround them. And when we convey that information through audio, for example, and we are talking about, for example, describing images, that's a way of transmitting information. But again, in the field of audio, we can also talk about sonification. For example, imagine that you are inside a drawing, positioned in the center of a drawing, and you hear the objects in that drawing speaking, each one at a time. For example, a red circle, and it's spoken as if it was on your right. And then you hear a green rectangle, and is spoken on your left ear. So, as a blind person, that person correlates the shapes in the space in a more efficient way than if it was only transmitted to them that a red circle is on your right and the green rectangle is on your left. And if you add to that the feeling of touch, for example, if you give them an embossed paper that represents a rectangle and a circle, maybe that person will memorize better that information, that visual information, and through multiple channels of input, they will build a better mental image of what is that drawing. So there are many different approaches to this, but the main thing that we can say is that multimodal approach is better than just one modality. I don't know if I answered the question, Dave.
You did, and I'm interested in this idea about experience between someone who is congenitally blind and someone who has acquired blindness later in life. If you ask a child who's been blind from birth to draw a table, they might draw a square with a line coming out of each corner, right? Which visually doesn't look like a table, but obviously it's got all the kind of the components. So how do you navigate those differences?
Yes. First, I want to point out that blind users have some things that they can't really understand at first. For example, the sense of perspective and the way the objects distort when we are seeing them. So it's a little bit strange to say that to a person who is congenitally blind. Or the overwhelming experience of you don't see, for example, the entire object. For example, think of a bus. If you are at some distance, you can see all the bus, but if you are really close to the bus, you can't apprehend the whole thing, of course. And big objects are always a difficulty for persons who don't see, because they can't apprehend a big object. And so we must have ways to deal with that. For example, in museums, we are seeing now, recently, replicas of big statues, for example, for a person that is blind to sense that statue in a smaller scale. So another aspect, for example, that is really difficult for persons with visual disability is color, mainly persons who were born blind. So how do you explain the color of grass? Or how do you explain the color of the sun or the sky to a person who is blind or congenitally blind? So for that, there are several approaches. In this time, at 21st century, you have to make a big effort to invent the wheel, because almost everything, someone has thought of that in the past. So Goethe thought about transmitting color to persons with visual disabilities. And the way he thought was, and we have this in theory of color, thinking about cold colors or warm colors. That's a way to distinguish, for example, the reds from the greens. So appealing to the senses of the person who doesn't have vision, to the other senses, to transmit an information that's purely visual. For example, green could be transmitted to a person who is blind by saying that it's a fresh color. You can feel the green when you touch with your feet in the grass. That's green. Okay, so conveying the information through other characteristics of the green color or green objects that we have. And my particular way of transmitting that information is through Gestalt. For example, one of the things that the Gestalt law says is that the person sees the whole picture first, and then it goes to the details. So if you look at the forest, you mainly see a bunch of trees and you say, well, this is a forest. And then you can concentrate in one tree and try to find out what is that species of trees that compose that forest. And then you can go a little bit further, and I'm doing now a parallel to technical drawings. You can say at first that you have a picture that is composed by a rectangle, a triangle, or two rectangles, a triangle, and two circles. And then you memorize that. You can explore all the times what are those elements and repeat the many times as you want to convey that information to your memory. And then you will explore the location of those objects. For example, there is a circle on the bottom left corner of the drawing. There is another one on the bottom right corner of the drawing. There is a big rectangle connecting the center of those drawings. and there is a triangle above that rectangle. What you are trying to transmit is that I'm trying to draw a car, a simple car with those geometric figures. Okay, but what I found out is that if you only convey that information through hearing, person won't get the real picture that I'm trying to convey to them. So that's why I bring the tactile aspect to this picture, to try to convey more information and to get people to apprehend the drawing faster than if it was only transmitted by oral information. Of course, we are in an era of artificial intelligence, and we can have descriptions of objects, and we can have that artificial intelligence looking at those shapes and trying to figure out what is trying to be represented there. But for my investigation, what I'm trying to do is to convey all the information of the drawing to a person. Okay, and I'm doing that by using Gestalt laws and by using navigation, thorough navigation through the drawing, to give the person the tools, the correct tools, to interpret the drawing at its fullest.
I find it fascinating when speaking with blind people about their understanding or sometimes challenges when it comes to accessing tactile information, right? Because if you feel a tactile representation of the profile of a dog, for example, like how do you know, is that a dog? Is it a horse? Is it a pig? Is it some other, four-legged mammal? And then you also mentioned, the problem of perspective, right? So that the legs on the other side might feel shorter, for example, because they're further away. A lot of blind people might find it challenging to identify, say, a 3D line drawing of a cube, for example, because it feels quite busy. There's quite a lot of lines in something like you've got all the vertices, represented.
So you're talking about a schematic 3D representation of a cube.
I guess what I'm saying is that there's a huge variety among blind people in terms of our range of ability to identify and recognize tactile drawings, and I observe this on a weekly basis, when we're out and we're showing people the dot pad, and we have it set up with the dot canvas app, and folk come along and make a drawing in Canvas, and you can feel that in real time on the dot pad. Sometimes people draw a flower or a heart or a house, right? And and I've become quite familiar with those sort of go-to shapes, but with something unfamiliar, how do we educate blind people in more effective use of tactile material? Because as you said, there's so much information is communicated visually, obviously in your field with technical drawings, but just in the world generally, right? And it's a whole sphere that we've only, I think, begun to unlock.
I also, while preparing my PhD thesis, I also studied persons with normal vision and the way they looked at drawings, and the way, because I showed them a bunch of technical drawings, and I tried them to memorize those technical drawings to draw them later. And they were of increasing difficulty, starting by a very simple drawing like a pyramid with the front view and the top view of the pyramid, and then evolving to more complex drawings. They all were 3D objects, but they were of increasing complexity. And one thing that I've learned through the way that people look at objects to try to memorize them, and I investigated the mechanisms they used to memorize things. And even in persons with a background of mechanical engineering, when I showed them a technical drawing, when they tried to memorize things, they were giving, for example, names to the things they were seeing that were similar to real world objects. for them. For example, they would look at a view of a technical drawing and they will say, okay, this looks like a door. This looks like a window. So there's a small window on the left of the door. And there's a thing that looks like a roof on top of that drawing. And so people try to establish those bridges in what they know while interpreting the drawing. Of course, when we are using tools like DotPad, for example, you can have the part of the tactile feeling of, for example, a pyramid, seeing from the front, for example, and then on the small braille ruler that you have on the bottom of the DotPad, you can read the information, what is being represented. And in my app, you can do that. You can just isolate a particular thing of the drawing and explore that, know what it is, because in a way you can build the drawing yourself, and on the other way you can interpret a drawing that has been constructed by someone else. So for that, you must have all the objects correctly identified, and then you have to build some kind of navigation for them to be intuitive to use on one aspect, and the other meta information. So each object can have a name, or each object can have some certain characteristics. And by using this tactile information and by using sound, maybe we are building inside a person with his visual disability the kind of information they need to learn those aspects of visual information, and starting to have a clearer mental image of the world. I haven't done any tests with the DotPad with users, but I'm starting them pretty soon because I'm already finishing my app. And so I will try to see if this is a way to go, but I have a feeling that's the correct way. Multimodality and trying to convey the information through various channels of communication.
You're listening to Raising the Dots, and we are with Vítor Carvalho from the Faculty of Engineering at the University of Porto. Vítor, you have developed or are developing an app. Tell us a bit about that project.
So, as I said in our previous conversation, my master thesis was about creating an internet-based website that would read an SVG image, and then it would convey the information on that SVG through speech. And person could navigate using the keyboard in that drawing and see what entities were there, what were their properties, and so forth. So now I'm building another web app that uses a connection to DotPad as well, and try visually disabled users to build their own drawings with the help of the DotPad, and using two ways of inserting commands. The first way is by using the keyboard and using commands that can be compared to regular CAD programs to build their drawings. And on the other way, they can speak to the app and say what they want. And the app will build those geometric shapes for them. And then they can output to DotPad those shapes. They can navigate through those shapes. They can see particular shapes, and they can see the whole picture or in quadrants. Well, they can navigate thoroughly through the drawing to comprehend them.
Who is your target audience with this app? Is it just engineering students or a kind of a wider demographic?
Well, I think that when we talk about those kind of drawings, geometric drawings, we can be talking about several subjects. We can be talking about a mechanical engineer or an electrical engineer that can see, for example, the circuits using the information through the dot pad and description. For example, knowing that the circuit has a resistance and has a light bulb and has an interrupter, for example, and see those symbols on the dot pad. We can always think about small children, for example, learning shapes, learning what a circle is, or learning what a rectangle is, or learning what a square is, or a triangle. For me, because I'm at an early stage of investigation, I'm sticking to simpler drawings, because I'm trying to find a path, a way for persons to better build images when they have a visual impairment.
You will be aware, of course, that there are a number of tactile displays now available. Mm-hmm. Why is DotPad a good fit for your project?
So I'm going to be terribly honest with you, and I will say that the biggest advantage that DotPad has when you compare to other tactile displays is the price. Okay, so when compared to others, that's a fraction of the price that others have. Okay, maybe they have some particular functions that DotPad doesn't have. For example, I can't press the Braille dots to select something. Maybe that will be a future development or another product by Dotting Corp. But for now, for my investigation, the DotPad had all the characteristics that I needed to transmit the information to blind persons, okay? And in a small price when compared to others, okay? When I was investigating, and I am from Portugal, we could have smaller devices than DotPad, that would cost us 17,000 euros. For a Portuguese institution, that's too much, okay? For a regular user, that's too much. That's almost the price of a car here in Portugal. So the price is the main advantage, and all the things that the DotPad brings, and I was able to see in these couple of weeks. So it's robust, it's well built. I can see that there is quality in the product itself, the materials they use, how the DotPad arrived here, the accessories that it brought. So all the things were adding up. And then it's easy to connect it to my computer. It's a Mac computer. And I literally can say to you that when I received the DotPad, maybe 2 hours later, I was already sending things to the DotPad and seeing my drawings be drawn in the DotPad. So I have the DotPad X. It's very quick, showing the images. It's very quick changing the images. So I can understand that it can have several uses for it. In the games area, for example, in the education area, of course. But for me, the most important in the DotPad is the portability, because some of those devices are bulky, okay? So it's difficult to walk around with them. That's not the way with DotPad. It's really portable, and it's easy to connect to the computer. And the SDK that they give to you, it was simple for me to just put it working in a matter of hours, because I want to have full control on the dot matrix of the DotPad. I want to raise that particular pin in that particular place. And that I was overwhelmed how easy it was using that SDK to, in a couple of hours, having the DotPad doing what I wanted.
And some multiline Braille displays that have Braille spacing and don't have that uniform distance between pins, I guess would be unsuitable for the kind of material that you are wanting to display, right?
Yeah, right. Because I'm transmitting visual information, I'm transmitting technical drawings. If there was a discontinuity, for example, in a line, maybe that would be misinterpreted by someone who was touching that line on the Braille display. or on the graphic display, sorry, on the tactile graphic display. So you mustn't have those gaps between the dots. They must be evenly spaced for you to convey the correct information.
Can you remember what was the first image you displayed on your dot pad?
Well, it wasn't an easier one because I'm doing tests with my app. I had several things in my app, several geometric shapes, and that was the first test for the dot pad, conveying that all those shapes into the screen. Of course, there are some limitations, maybe some technical limitations. I don't know them, but the dot pad has 60 by 40, I believe, pins, and of course, technical drawings can be huge. So the way I'm approaching that is to transmit the whole information with less detail on the tactile display, but you can scale drawings up. You can just draw portions of the drawing, say, for example, in quarters, first quarter, second quarter, and so forth. And you are navigating by areas to understand and to see all the details with increasing capability. So starting by knowing all the positions and then going to the details.
Are you making any use of Braille to label parts of your images?
Yeah, of course. For the person to the commands are always spoken to the user. So the person introduces a command, for example, the command to see the drawing on the dot pad is out. So you say out, and then you see the drawing on the dot pad. And then you can say, for example, alt square 1, and then you will only see the square 1, that's the name of the square 1 on the dot pad. And you have on the Braille display, you have that label associated with the object for you to read, okay? Imagine if it is a small kid, for example, using dot pad, you can have the shape on the tactile display for them to know what a circle is, and then on the Braille display you can have the word circle for them to learn what is a circle and learn Braille at the same time. So the opportunities here are unlimited.
What's the next steps then, do you think, Vítor? Are you going to make the app available publicly, or do you still have some more work you need to do?
Well, as it is, I could make it available publicly. I just want to first polish some things that aren't too polished yet for my taste, and second, present my PhD thesis. And my idea is to bring it available to the public.
You mentioned it briefly earlier. What are your thoughts around involving blind people to test your work?
Well, that's paramount. When you are doing an object to be used by a particular group of persons or by different persons, you must always have testing users. And because I'm doing an app to be used by the visually impaired, of course, I must have visually impaired persons testing my software. And I won't present my PhD thesis without that. I'm looking forward to test my application with 20 blind subjects, maybe, and trying to gather the information that I need to turn my app even better by the input that those users will give to me. So I think that's a crucial step. And because this is a research project, of course, we must have data. We must see if this is better than don't have those multimodality ways of transmitting information. We must see if my software is easy to use. We must see if the user isn't overwhelmed by information. So there are lots of questions that I must answer in my thesis, and that must be gathered by data coming from subjects, blind subjects in this case.
Are you seeking testers now, or is that opportunity still to come?
I'm seeking testers now. Unfortunately, I'm in a company that already does testings with blind users, and I will ask the company to contact them and trying to find out if they want to collaborate in my thesis. I can also send emails to the University of Porto community to know if a blind student wants to participate in this investigation. And of course, I know blind persons in the University of Porto also to see if my app is good or not.
Are you making any use of AI?
Yeah, of course. Who doesn't? But for example, for me, I said earlier that it was really easy for me to connect to the .pab and him doing what it was supposed to do, represent tactile information through my app, and I just gave the SDK to an artificial intelligence program, and it digested the SDK and gave me, in a matter of 1 hour or two, the ways to communicate to the pad and the things that I needed to have in my app in order for me to connect to the pad.
What do you think makes an impactful tactile diagram or tactile experience?
The main thing that we need to learn is that users apprehend the world differently from each other. So the experience that a blind user has is different from the experience of a sighted user. For example, I work on the internet, I do stuff for the internet, and I'm an accessibility expert. So if you are talking about a picture, for example, a picture that is on the web page, the way the persons with normal vision look at the picture is different from a person who is visually impaired. So that person isn't really interested in all the details of that picture. The person with visual impairment primarily wants to know what that picture tries to convey. So instead of having a romance in the description of the image, you must have a relative small text that conveys what the image is trying to convey. And the same thing occurs with visual drawings, visual technical drawings. We can serve the person with the aspect of that technical drawing through the graphic display, but the way that the person will memorize the image or the way that the person will understand the image must be conveyed in a way that will, for example, as I said before, respect the cognitive load in one side, and on the other side, the way that a blind person perceives the world by using multimodality and by transmitting the information through various channels: Braille, tactile, audio feedback, sonification, for the person who isn't capable to see, to apprehend the image through those channels of communication. So we must understand that. Of course, there are some parallels that we can establish between the way the persons memorize things, but we must always adjust to the user, the information that we will give to them. Mainly persons who were born congenitally blind. They don't have visual culture. So we must transmit them visual information in other ways.
What story is the image trying to tell, I guess, is the question, right? Because the color or the perspective or the lighting may not be the most important features.
Yeah, of course.
Where would you be without .pad? To what extent will it support your work?
I was eagerly wanting for a .pad for almost a year now. That was because of the bureaucracy associated with buying stuff for the university. And without the .pad, I couldn't do my PhD. So I was eagerly waiting for this .pad. And when it arrived and I was able to send information to the .pad in a matter of hours, I was relieved. because I now know that I have the stuff I need to finish my PhD thesis. Okay, in a relatively affordable device that has all the capabilities that I need to explore this kind of subject. So transmitting visual information to blind users and enabling them to create digital drawings and maybe display them in a Braille embosser printer, for example, and maybe a way for a person with a visual disability to continue their work as they were before losing their vision. So it's a great opportunity. I'm learning a lot, and I'm exploring something that I think it wasn't really explored, because all I listen around here is just conveying information to blind users, but enabling them to produce visual information. I think it's powerful, and we have the right tools for that. For example, when I started my PhD, I didn't have tactile displays at my anywhere. Okay, that's a recent technology. And the ones that they were a few of them, and they were very expensive, and they were bulky. And so price, portability, it's the main difference of the DotPad when you compare to other devices.
Vítor, for listeners interested to learn more about this subject and your work, do you have any links or recommendations or ways that we can stay in contact?
I will have soon the project available online, and I can give you information about that later, and you can just convey that information as well. But my research is public. If you try to search for my name in, for example, Google Scholar, you can see all my previous work. My master thesis is also online. I can give you the link for that after this conversation, if you want. And maybe in that website where I have my master thesis, I will have a link to my PhD thesis when it's finished.
Excellent. Well, any links that you share, we'll be sure to add to the show notes and get that information out to listeners. Vítor Carvalho from the University of Porto, thank you so much for joining us on Raising the Dots.
It was a pleasure to have this conversation with you and to have the opportunity to show the world my work and my experiences with DotPad. Thank you.
That's it from Raising the Dots this time. If you have a comment, question or suggestion about something you would like to hear on the podcast, drop us a line. Our email address, it's info@dottingcorp.com. That's info@dottingcorp.com. But for now, from myself, Dave Williams, and the rest of the Raising the Dots team, until next time, bye for now.